So it's a real pleasure to be here at a Zinnov event to talk about the 20 years of Agile Manifesto and what's next. One part I wanted to mention here, and I'm going to go and historically date myself a little bit. I had the opportunity of working in this area when, in my first job after my PhD, I worked at Hewlett Packard Laboratories as part of the software engineering environments group. And those were the early times of people that we work with, including Barry Beam from the USC. We had a partnership with several other people who eventually became founders of ClearCase, and some of the work that happened out of the Grady Booch and the whole rational related stuff. So I had an opportunity to be at the exciting part during the early parts of this thing. So clearly, we are celebrating today the 20th anniversary of the great Agile Manifesto. But before we go too far, I wanted to ask this question. So, why did we need an Agile Manifesto in the first place? And if we needed one, why did we need one in 2001? And we have been writing code pretty much since the 1950s. And clearly, software engineering has been around for a while. And why did we have to pick up Agile Manifesto in 2001? So I'm going to trace a very brief history of the software industry and what the challenges were and how this evolved and what led to the Agile Manifesto first, and then spend a little bit of time trying to explain to you what I believe are my opinions moving ahead and what might be the next set of things. So clearly the Apollo program was considered a huge success, but by and large, software in the 60s and 70s was pretty much considered a train wreck. A lot of disasters, a lot of delays, and many challenges. One of the earliest, it was kind of at that point, software and writing code was considered an art. And this set of books that are very famous, written by none other than Donald Knuth, talks a lot about the art of computer programming. And he started writing these books in 1968. So even he felt that programming was really an art. And in some cases, it was even considered magic art in some sense. One of the earliest chronicles around the kind of challenges that we see in software were from Fred Brooks. And Fred Brooks used to be an executive at IBM and then eventually became a professor in North Carolina. And he wrote a very seminal book in this area called The Mythical Man Month. Even though the book is fairly old now, it's from 1975, I highly recommend you all to read this book. It's got some amazing stories of software in the early days. And there is a 1987 article on IEEE computer that is very important. I think the key thing in these articles was that when they were comparing software as compared to hardware, which was already moving at Moore's law pace, and you could see the amazing investments, average software projects were 50% late. Half the projects were operational but not exactly successful. And most of the product failures were there because they did not meet customer requirements. And by the time we came to the early 80s, there was a consensus that because of lack of agreement on requirements and the ability to uh, fix those or understand really what meant that you had a lot of feature creep, and fixing bugs early was found to be significantly better than finding them later. So if you could find the bugs early, you could fix them better, it would be much faster and cheaper. So there was this whole method around that, and that led to what was known as the waterfall model. So the idea is that before you get to the next stage, get the commitments, rule out the bugs as you can as early as possible in the process, so that when you get to the next phase of the process, they are already cleaned up and you don't have to go back and fix them and spend the time on testing and deployment and all of that. So this was pretty much how this happened. And the DoD was very supportive of this model. There were many IEEE standards that were written about how software should be delivered in these kinds of contexts. On a personal side, I was quite actively, we were had started Persistent by this time, and we were working with Microsoft very closely in the early 90s. And Windows 90, Windows NT was one of the versions that really got delayed. And we personally, had some sense, we benefited from this delay because we got a chance to work with a Fortran compiler that we would not have gotten to work with if NT had shipped on time. But because of these delays, which were all written up a lot, Microsoft went into overdrive to try to see what kind of processes are needed, how do you build all these processes, and how do you fix the setup. And one of the seminal books around that time, which I think is still worth reading, is this Kusumano Selby book on Microsoft secrets. This would have been from the early 90s, 93, 94, 95 timeframe. And there was a lot of discussion on how Microsoft improved their processes. And a lot of energy was spent by Microsoft in trying to encourage people to write code which was cleaner. And there was this set of trilogy of books around Code Complete, Solid Code, and Rapid Deployment that were pretty much the standard Bible for everyone who was writing code at that time. In the early years of Persistent, I was very influenced by these two books. One is this Principles of Software Engineering and Management, and then Developing Products in Half the Time. So this particular book by Smith and Rhinestone, they have written this book about Black and Decker and how Black and Decker was able to improve the development process very effectively. Very nicely written books, all pre-Agile in some sense. Around 89, Watts Humphreys, who used to be at the Software Engineering Institute in Carnegie Mellon, wrote this book called Managing the Software Process, and then eventually wrote this book called The Discipline for Software Engineering, which was all a precursor to the CMM model. So this was really where it went, and we had this model of 5 steps, CMM 1, 2, 3, 4, 5. And this came in from the Software Engineering Institute at this Carnegie Mellon University. And India was very active in the CMM thing. Pretty much every company jumped into the CMM bandwagon. This is a very famous book written by Pankaj Jalote around the time Infosys went through this whole process. Motorola India Software was the first CMM 5 certified lab anywhere in the world. And Infosys was one of the first Indian software outsourcing companies to be CMM 5 certified. CMM was a very popular thing in India. Every company pretty much said that they need to be CMM 5. If you look at government RFPs today, pretty much all of them refer to companies needing to be CMM 5 as one of the requirements. And this was a very active thing to the extent that I knew a few companies that did CMM 5 even before they wrote the first code. So it's kind of ironic that you have a business which has no software business to start with, but is already certified at CMM 5 because they had the processes all in place. From our side at Persistent, we struggled to get into the CMM 5 kind of bandwagon. We tried a couple of times, but we never could make it. And that's when we started to differentiate ourselves as outsourced product development. And to do that, one of the things that we found is that CMM was pushing IT outsourcing processes around the software development lifecycle, where you have well-defined requirements and you did trade-off between time and effort. We were more actively working with product companies, and product companies typically followed PDLC, which is the product development lifecycle, where the time was fixed, the effort was fixed, and the trade-off was mainly on the requirement side. So you got to define requirements per cycle, and this sort of was a precursor of the agile development stuff in that context. Taking the discussion back to 2001, clearly by this time, the process groups in companies were very dominant, and people had missed out the fact that, we were building software, we were working with individuals, and the entire process about how you build software was all about these CMM type, very heavy software processes. So when these 17 leaders met in Utah, they were sort of very keen to see how to rewrite the manifesto. And some of the key things that you note in the way they defined it, it was sort of a rebel movement against the process movement that had become very common with the DoD and the CMM structures going in fairly active. And this is sort of where it came in. And over the years now, we have multiple frameworks and lots of development processes. And it's become, again, large number of options. And I'm really looking forward to Scott in his presentation, where he has been thinking about all of these issues and has suggested a methodology which is excellent. And I'm sure he will talk more about it. But essentially, we are starting to see a whole mix of processes and ideas and things that need to be done. And I wonder if we have gone, the pendulum has swung again in the other direction. Are we getting too process oriented and not thinking about the individual's processes and the software artifacts that we are building? So as I look ahead now, and what has changed since 2001 that we sort of look at it ahead in the next 20 years that we have seen since 2001 to 2021, And what is different now, and does the Agile Manifesto fit in the context of 2021, and what might be everywhere ahead? So clearly, the first, I think, important thing to note is that post the great article by Mark Andreessen that software is eating the world, every business has become a software-driven business. So software is no more written by just people from the software companies, but it is being written by people across every company, and every business has become a software-driven business. There has been a lot of buzz around this whole concept of two pizza teams, so teams that take full accountability and ownership with aligned incentives. So instead of having this model of saying we have one team that does development, one team does the testing, and on so on, we are now sort of moving into a full team that is two pizza teams, a small team that does everything around the product end to end, starting from dev, test, QA, everything. And then clearly we see a big trend around improved abstractions and automation and various other things. And the comment that I would make here, and this is something that everyone needs to note, is that the effort required for the same work is going down drastically or exponentially, depending on who you ask. But the fact is, today we need many fewer people, far fewer people today than we used to need in the previous generation of software as it was written. So today teams are becoming far more efficient. You have better tools to write code, and things are starting to happen in a much more different way as compared to the previous world. So how does Manifesto have to be relooked at in this new context? And finally, AI has come in everywhere. It's, in my opinion, we are still on the runway as far as the AI is concerned, but in the next few years, it's absolutely set for takeoff. So looking ahead, I just wanted to comment a bit on how Agile has evolved, and I sort of mentioned this in the context of the two pizza teams. So clearly, design, implementation, testing have started to coalesce. We start to see teams that combine design, test, implementation already. And this is sort of what you see in the two pizza teams or full stack development or any of the concepts that we hear. A developer is not restricted to either just design, implementation, or testing, but they are responsible for the entire process of dev, test, and now including the way things have moved, including the ops. So now we have this whole DevOps, test, everything all part of it. So while this has been going on and we have seen tremendous success in the DevOps world, and there is a full sort of methodology and strategy of how people are building code using tools all the way from coding to operations, and then back taking that feedback and feeding it back into the next round of operations. And this has really helped in building code where we are shipping products very frequently, and some of the best ones are shipping several times a day. So this whole cycle of how fast you are building code and deploying it has really improved in the last 20 years. As we start looking at DevOps, and I find that I'm very intrigued and excited by the sort of the changes that I have seen around site reliability engineering and SRE. So as DevOps has become mainstream, the top companies led by Google have taken a fresh look. So what they started to say is that, traditionally people who did the operations work tended to be those who were system administrators and people who were just operating things, and they were looking at things as to saying, how do I go implement this or deploy this or that? So one of the ideas that Google said is that, let me put the best programmers and kind of ask them to relook at how software DevOps is working, and can we do it in a way where we can reduce the organizational silos, assume that failure is normal, build out reliability by assuming how to manage failures and work against failures rather than tracking failures and dealing with them. And then they all talked about how you would do these changes gradually and incrementally, but do them continuously in some ways. And then one of the most important things that I have found in terms of how SRE has been looking at this is to try to put in automation to, get rid of processes that have been very tedious and measuring everything. I'm quite excited about how SRE has evolved in the last few years, and I somehow believe that SRE would be a good place where for the future of development as well. So while SRE started out as being something that is used for operations and monitoring, I believe that SRE principles will start to come in very handy into the coding and testing and various other changes that we see. So before I conclude, I want to make one bold claim. And my claim, this is a 20-year horizon claim. I believe that artificial intelligence will change the way we write code. Everyone will write code, and most of us will write very little code. So this is really what I believe is going to happen. So what everyone will have to write code in the sense that coding will not be restricted to only those who are programmers or whose job it is to code, but everyone will be writing their own sort of add-ons or in some ways programming their interfaces or whatever else. So everyone will be effectively programming their VCR or anything else that they might do. But to program any of this stuff, you will have to write very little code because most of the code will get generated. So this is sort of my bold claim for the next 20 years. I'd love to, have people disagree with this or comment on that. The challenge that I see right now in terms of the programming environment as to where the next frontier is and where some research and activity needs to happen is around requirements. So while it was identified in the 80s that requirements was a big challenge, and the whole reason for Agile was to ensure that the requirements, implementation, dev, test all happened in shorter cycles, as we get to an AI-led programming environment where coding is not going to be necessary and machines are going to write code, how are we going to specify our requirements for the machine? So that's really going to be the biggest challenge. And I think that's where some research and new activity has to happen. And I'm quite confident that you will see some new action in this area. And then the now opportunity that I want to share with all of you is the following, that I believe that the top 20 companies, and I'm just making 20 as a number, but when we work with some of these companies who have the sort of the best of class DevOps plus test, QA test, DevOps, and SRE implemented, they are delivering software almost at 2 orders of magnitude more efficiently as compared to the laggards. And I see that difference actually starting to get starker and starker as we look ahead. So the well-oiled machines are delivering software at a much better efficiency, fewer people, less time cycles, more and more releases, and better speed at which they are delivering stuff. And I want to leave this as an opportunity for the Indian software industry into saying that, does it make sense for the Indian software industries to look at some of the processes and methodologies that these top 20 companies may be using and make sure that we can actually democratize this whole activity of software development across the industry so that we can build as efficient software as these top companies build for everyone in the universe. So that's really where I want to stop. I don't know if we have time for questions. I'm going to hand it back to Zinnov to see what may be the best way forward. But thank you very much for being here. I'm really looking forward to the panel and the next session by Scott. So look forward to it.